This is Newton's second law in vectorial form. And so that means that the acceleration vector is going to have some components in the x and the y. Now, it could, of course, have a component in the z direction, but I'm going to stick to the xy plane for this video. What I would like to work through for this video is what is the form of Newton's second law written in polar coordinates. So instead of x hat and y hat, which are unit vectors in the Cartesian coordinate system, how can we write it so that f is written with r hat and phi hat? So what that looks like is here is the xy plane, x hat, y hat is written there. If I have, let's say, a position vector here, r, I could write r as being equal to x, x hat, plus y, y hat, where x is just some scalar. In case this doesn't make sense to you, x hat, or a unit vector, is a vector in which its length is 1, hence unity, and we will multiply a unit vector by a scalar. The scalar just acts to increase the size of the unit vector, right? Scales it. And so we can tell you where your position is by some linear combination of x hat, y hat, and scaling those unit vectors appropriately. But I could write r in terms of polar coordinates. So let's write r vector as being some r scalar multiplied by r hat. So r hat would be right there, like that. And then r just scales to the appropriate length, right? That's what that is. To continue on, there are a few relationships we need to work out. First, what is r hat? Well, r hat is going to be cosine phi x hat plus sine y hat, where phi is here. Now, what if I took the derivative of r hat with respect to phi? Well, it's the derivative of this, which is going to be minus sine phi x hat plus cosine phi y hat, which, as it turns out, is equal to phi hat. Next, what is the derivative of phi hat with respect to phi? Well, it's the derivative with respect to phi of this, which is minus cosine phi x hat minus sine phi y hat. Pulling out the negative, we can see that this equals minus r hat. The next thing to note is that the dot product between r hat and phi hat is equal to which is equal to 0. In other words, r hat dotted with phi hat is 0, or they are orthogonal to each other. R hat points here this way, and phi hat is going to point this way. It's right here in that direction. Okay, with those in mind, we can now get started. Starting with this equation, we will take a time derivative. Here is the product rule. Okay, now the next thing we need is to apply the chain rule. I have dr hat dt, and that is equal to d phi dt dr hat d phi. Which then allows us to write this as there. Next, let's write the second derivative like that. So we are taking the time derivative of that. So I've just applied product rule there. And then this one has 3 terms. So 1, 2, 3. Again, we can apply a chain rule. And chain rule here too. There we go. And the next step, but instead of these, this is now phi hat, and this is now minus r hat. And now we can factor out the unit vectors. Two of them, and there's a minus sign. Carry two. The next thing to do is to multiply everything by a mass. Because then we have a force vector, and now this is my F R hat plus F phi. And there we go. This result here is Newton's law in polar coordinates. Now there are four terms that you can see, so let's go over what they mean. The first term, dr squared dt squared, all this is a radial acceleration. So here's a radial vector, and I am accelerating in the radial direction, right? The second term, minus r, and it's going to have some tangential velocity. Well, it's in the radial direction, right? It's minus, so it's towards the center. And I could write this as, and we also can work out that if I had something swinging with length L, it's going to sweep out an arc. The tangential velocity is going to equal the length of the rod and the angular velocity. All right, another relationship you may have seen before. or should be familiar with. So I can rewrite phi dot as v over r. So we have minus r v over r squared. So r v squared r squared. One of the r's cancel. And this is, of course, the centripetal. So this is a centripetal acceleration. And of course, it multiplied by the mass, you have a centripetal force. The next term can be written as r phi double dot. This is just a tangential acceleration. The last term to talk about would be this term. Or rewriting that as 2m r dot phi dot. We can
Thank you for
write
watching my
this
video, and if you enjoyed it, feel free to give it a like
is
and
called
subscribe for more content.
the, the Coriolis Force. That's the term for the Coriolis Force. There's a lot more to say of this term, of course, but that will be another video in itself.